Well, I think it's time to start now. The time has come. Hello, everybody. My name is Bruno Wittmer, and together with me is Michele Oriosi, my side. Welcome to our webinar today. Thank you for joining. In our webinar today, we will present the new PVsystCLI version 8 together with the command line interface. And the webinar will be divided in 3 parts. Michele will start by presenting the novelties from PVsystCLI version 8. After that, I myself will be presenting PVsystCLI CLI, the command line interface. And then after that, we'll have some time for questions and answers. There is a small technical team behind the scenes, which, by the way, I would like to thank for preparing everything for this webinar. And they will be already taking questions while we are presenting. So in the chat, you can just put your questions while we are presenting. Some of them will already be answered, the easy ones, and then what remains to be answered in the end, we will take after we've finished our presentation. So without further ado, I will pass to Michele, who will go on.
Thank you, Bruno, for the introduction. So yeah, we'll do the first part where we present the novelties in PVsystCLI 8. Just a reminder, so this is mostly based on the same thing we presented last week in the webinar last week. And so we'll cover the same subjects, but still feel free to ask any of your questions. And so let me start the presentation here. All right. So in basically version 8 has now 1 month. It was released on November 7th, 2024. And we are now at patch 8.0.4 that was released just yesterday. And so I invite you to update your versions to benefit from all the latest crash corrections and other improvements. And so PVsystCLI 8 is available on our website. It's very easy to download. You can visit the page that is on the slide. And there you will find an installer that will install both PVsystCLI 8 and PVsystCLI CLI. And so PVsystCLI CLI will be completely presented by Bruno a bit later. But I just want to say that both products can be evaluated. Once you download them and install them, you have 30 days to use PVsystCLI with full features and 60 days to use PVsystCLI CLI within the limit of 250 calls. And so you can just start right now and start and download the software. And so now let's look at what was the state of PVsystCLI 7 and what were the limitations in PVsystCLI 7 and why we decided to develop PVsystCLI 8. So PVsystCLI 7, in particular the last version, PVsystCLI 7.4.8, is quite robust and can model many diverse complex systems. But it has one fundamental limitation, is that most of the times one variant corresponded to one orientation. And so this had basically 2 problems. First, because for very complex systems, for example, if you had fixed shields and trackers together, it was not possible to model that in PVsystCLI 7. And the second problem was that in most of the cases, since we had only one orientation or one type of orientation, we also had only one representative geometry for the modeling. And so that was limiting because it could limit the accuracy of our calculations. And so this has motivated us to develop PVsystCLI 8. There we go. And so PVsystCLI 8 is all about lifting that limitation. We wanted more types of system to be allowed just by allowing any type of orientation to be added to the same variant. So this has therefore 2 benefits. First, that we can model as many systems as one wants, as complex as one wants. And also that the results will be more accurate because we'll be able to just capture those different geometries that you have on your system. And each of them will be modeled separately with an orientation. And so in the end, we won't be averaging over and making some average error. And so what this means in practice, I'm now going to switch to PVsystCLI. So this is PVsystCLI 8. And let's look at some examples. So I will start with a variant that has two orientations. Let me show you the 3D scene very quickly. So here we have one field with fixed tilt south-oriented tables and another with vertical east-west oriented tables. And those are supposed to be bifacial. And so if I now look at the orientation, here we have our new orientation window that reflects that orientation choice. So those two orientations will be displayed here. You can already see with all the space that is added that we can add many more. It is now very easy to basically take a quick look at all the orientations, and you can also unfold these orientations and then go into the nitty details of each of them. And it's going to be very easy to just change the parameters and add new orientations as well. And so, for example, here I could add the tracker orientation. I'm going to add this simplified geometry so that I don't have to modify the 3D scene. But here we have some trackers, and it can, without problem, coexist with the other orientations. So now, let's try to simulate this. So first, I need to add some actual modules and inverters, so a subarray to my new orientation. So I'm just going to copy this subarray here and assign the third orientation, the one I just created, to it. And I'm ready to simulate. So now I can just run this here. And now, if you look at the report, then you will see all this variety of orientations being also displayed in the report. So in the first page, you already have a summary of these orientations. I'm going to zoom in a little bit. So here you have the summary. Then each of them is given in more details in this general parameters page. And if I go down, I will have specific losses for each of them and so on. But you will also find iso-shading diagrams for each of them. And so you will see that you will be able to have a lot more detail in the report. Finally, if you look at the loss diagram, this doesn't change. Of course, in terms of calculations, we're aggregating all the results of the system in the single loss diagram. So here we're just looking at the results for the whole system. With this variant, I already want to show you a specific feature that can help you define the orientation. So we have seen how to add an orientation before in the orientation window, but you can also build fields in the 3D scene and then visualize which orientations we're dealing with. So we here have a new tool that has the orientation management button. This will allow you to assign subarrays to orientations. You can just drag and drop from here. You can also select specific orientations in this list and also color these orientations with different colors so that you can easily differentiate them. And so all of this is to be able to manipulate orientations a bit more easily. All right, let me show you another example that exemplifies something that we could not do in PVsystCLI 7. So I'm not going to save this variant. So now let's look at this one with the 3D scene again. So here we have 6 orientations. Those are fixed tilt orientations, and we want to make them all bifacial. And so this was one of the limitations in PVsystCLI 7 because since we only had one representative geometry, one type of orientation, we also had only one bifacial model. And now it's possible to have one bifacial model per orientation. So now we're going to define each of these orientations here separately. And if I look at the system, we'll have 6 subarrays that you can see on the left. And each of them has a bifacial system. So for example, here for orientation number 1, which shows up here again, we have a specific modeling of this bifacial geometry. And the same could be said for orientation number 2, which has its own geometry with a different azimuth, and so on. And so this is part of the novelties that one can achieve with PVsystCLI 8. As a final example, I will jump to the example with trackers. So we have a warning here. So this is just because we have a complex scene with averaged orientations, but this should work just fine. So let me render it again. So here we have 3 patches of trackers, and these 2 here, the ones in front, they have a wider pitch. And this is just loading. And the patch on the behind the 2 other has a pitch that is a bit shorter. So here, basically the GCR is higher. And so if you were to simulate this in version 7, you would have to average everything into 1 orientations, and all the trackers would then move in the same way. And so in PVsystCLI 8, what we did was separate the way trackers move per orientation, which means that we can now define 2 orientations, one for the patch that is at the back of the scene, and another for the ones that are in front of the scene, and they will move separately with different GCRs, basically. I can look at that in the backtracking management. So here you can see, I can select which orientation I'm looking at, and then the parameter will be adapted for each orientation. And if I take this example for these 2 first patches, PVsys here is telling me with this warning that some of the trackers, because of the GCR, might be shaded by this algorithm. So then I can have a look at it and see whether I need to move them or not, and whether I have to consider some change in the backtracking parameters. So this is quite practical. All right, so going back to the presentation, we also have implemented other developments, not just adding orientations. So I want to discuss basically 3 paths. So maybe the first one is we also try to make the simulation itself more accurate. And this is always an ongoing effort at PVsys. The example I will discuss is the sub-hourly clipping correction. Then I will also discuss some general improvements, some more quality of life improvements. And then I want to emphasize here that we also update our databases regularly. So right now, for example, in terms of weather data, we have Meteonorm 8.2. In terms of components, we keep adding more optimizers, more modules, more inverters. So this is a continued effort, and you also have these updates in every other patch. And so just if you're interested in the details of all the improvements, of course, you can look at the release notes. Those are found in our now help page that you can find in this address that is shown on the slide. And there you will find all the details about the latest improvements. So now let me go a bit further into how we make the simulation more accurate. So one problem was sub-hourly clipping. This is a well-known problem that if you run simulations as PVsys does in hourly steps, you may be missing the losses that come from high-frequency irradiance fluctuations. This is because if you look at very short time scales, you may have irradiance that fluctuates very strongly, and the production of the DC array may cross the clipping threshold of your inverters. And so if you're averaging over 1 hour, you may miss all of these features in the irradiance time series. So so the method we used to correct this was actually utilize the sub-hourly weather data. And while you can import this sub-hourly weather data in PVsys, this was summarized into hourly steps, but we now store more information during this step. So we basically store some extra hourly quantities that allow us to then remodel what was the distribution of the irradiance within each hour. And so in practice, you just import your sub-hourly weather data as you usually did, but just adding 1 click more on clipping correction. Then you can use your weather file, your MET file, and then you can just simulate. and the results will show kind of an extra loss that will just accompany the usual clipping loss. You will see that this clipping loss may increase when using this feature, and we will tell you what's the part that was attributed to that sub-hourly irradiance fluctuation. So now let me change to another subject, which are the more quality of life improvements. I will discuss two specific features. First, the import of topographic data directly from the 3D scene, and second, the new help page. And so I will go back to PVsyst again. Okay. All right, so I'm gonna load another project, which is now Demo Residential. This is a project that you will have in your installation. And we will just look at either variant is fine, but VC1. And let's now have a look at the 3D scene. So let it load. Now we can do the same thing as before, in which we identify the different orientations. That's possible also on small scale projects. What I want to show you now is how to import the topography. So I go to File, Import, and then download the satellite ground image or ground data. And so here, this image will show basically the satellite view at the location of your site. And so then you can just move around, select the exact location that you're interested in, and what will be imported is what you see on this window. Then you can also check this box, which will, on top of the satellite image, will also import the topography data. And then just press OK. And so there you go. You now have imported a topography, and you can start building and moving your objects on top of this topography. So you have two layers here, the ground image and the ground object. The ground image is not a shading object, so you can move it around as well and set it at a transparency or not. So yeah, that's it for this new feature. And now I want to check the help as well, just to show you this more advanced help. So this has been quite improved in terms of first, just aesthetically. We have also dark mode, and we have also improved the search functionality and the pages, the content of the pages overall. So if I search, for example, PR, it's going to be very easy to find the page you're looking for. All right. So now going back to the presentation, I just have my summary left. So basically, PVsyst was released in November, and now we're at PVsyst 8.0.4. Sorry, PVsyst 8 was released in November. And please update your PVsyst version. You will benefit from many improvements already. If you have a PVsyst 7 license, you can just use it and carry it over to version 8. This is a seamless operation. And the main changes in PVsyst 8 are first the multiple orientations. Then we have multiple changes that make the simulation more accurate. In particular, the sub-hourly clipping correction if you have sub-hourly data. We also have some new quality of life tools, such as the 3D tools, like the topography import and so on. And finally, we have PVsyst CLI that is also shipped with PVsyst, and this is where I pass on to Bruno.
Thank you very much, Michele, for this nice overview of the main new features of PVsyst. I will now talk a little bit about PVsystCLI. and what it was meant for, and which features right now exist. So if you have PVsystCLI, the desktop version with the graphical user interface, you can do a lot of things already. I mean, you can gradually change your design, rerun simulations. You can even use the batch mode for a little bit more of automation. But in general, if you use the graphic interface and have to interact with it, it does not integrate seamlessly into an automated workflow. And it might be necessary today, or very often today, people have automatic workflows and would like to integrate also the PV simulations from PVsystCLI into this mechanism. And this is where PVsystCLI CLI, so PVsystCLI command line interface, comes in. Instead of doing many repeated operations with your graphical user interface, you can automatize now some operations with PVsystCLI and use launch PVsystCLI operations from a terminal, from a command line. And this opens also the door to integrate that into scripts. Yeah, so this opens many new possibilities to automatize the workflow. And I will show you a few examples. Before I do so, just a few words how it generally works. So you launch PVsystCLI CLI on a terminal. There are some operations that you can execute. Some of them concern just the management of your license or checking the version that is installed. And there are two main operations that are right now implemented in PVsystCLI CLI, which is generating weather files from custom data. So import data, convert it to the PVsystCLI internal format so that you can use it for a simulation. This right now has to be done manually or with PVsystCLI 7, or if you use the graphical user interface, you have to use the interface that does a custom format importing of weather data and which generates then the .mat files. And this can now be done automatically with the PVsystCLI CLI. And the second operation that you can do is to just run a simulation for an existing project and existing variants. So you have your workspace with your projects and variants, and you can launch a simulation from a command line instead of going through the graphical user interface. And by launching this, you can also select the weather file that will be used and the type of output you want to generate. And I would like to show an example to you. Just let me say, repeat what Michaela already said. If you want to test this yourself, you can do that with a normal regular PVsystCLI 8 installation. PVsystCLI will be installed along with PVsystCLI on your machine while you're installing. And then you have 60 days and 250 calls as trial, where you can try out this functionality and see if it is useful for you or how it works. So to use that, I will start a command line interface. I would need a command prompt in the workspace I'm working. Hold on a second. I'm looking for PVsystCLI. So the command prompt, I will start in the workspace that we're using now for these examples. And to open that with my Windows Explorer, I can just click on the link that is shown here for the user workspace. And there you are in a Windows folder in the workspace in which you are working. And these are all the folders where PVsystCLI keeps its files. You don't necessarily need to work in this folder with your command line. It's just for these examples I will do this so that we can easily see the results. So next I will open a terminal. Let's see if I manage to do that from here.
I think you can type CMD in the bar, in the search bar.
In the search bar.
So here directly. Click, yeah.
CMD. Thank you, Michele. So I open a terminal in this folder, in this directory, and there, since PVsystCLI was installed, on this machine, I can just type PVsystCLI, and this is now a command that will be recognized by the prompt. If I don't put any parameters behind this, I get the message that I did not really specify a command, and I get a list of the available commands. Basically, it's a list that you've seen before on my slide, where I highlighted the two that I want to discuss. If I want to get some more help or some more information on how this works, I can either look up the help pages, which are also mentioned here when you do this. So you can look on the web on our site and get directly the help for the command line interface, or locally PVsys during the installation installed also a copy of these help files, and you can just visit them locally on your PC. You don't even need an internet connection. And here, the last line is a suggestion. If you want right now some more information on these commands, or just want to be reminded which parameters you want to pass, you can do this with a help command. So I can type PVsystCLI help, and the command I want to show you, what we'll try to do is just to run a simple simulation and create a PDF report. So the command is called run -simulation. And if I enter this, you see I will increase a little bit the window so that it's easier to read. You see an explanation of the command and all the options that can be passed. So this run simulation has many parameters. You can change the weather file that you use as input, which I will not do right now. You can create ASCII output files, CSV files for the output. You can create a PDF report. This we're going to do. And you have to specify the workspace, the project, and the variant that you would like to simulate. So let's just do that. I type now PVsystCLI, run simulation. As the first parameter, I need to indicate the workspace. And you see it's the last parameter that's written here on these lines. And as you might have noticed, for each of these options, there is a long version, which is explicitly written out what it's doing, or a shortcut if you want to be faster. So the long version is human readable, it's easier to read, and the short version is human typable. It's easier for humans to type those. So I will use the short ones and specify the workspace. And since I'm already with my command line in the folder of the workspace, I can just type dot to use the current folder. Then I have to specify the project. For this, I will quickly look up the name of the project that Michele was using. So in this workspace, I see that this is the name. And I will just copy paste this to my command line. And then I have to specify the variant. -v is the option, and it will be VC0, so the first variant inside this project. So this will launch the simulation, and now I also want a PDF report to be generated. So the option is report PDF file, or the shortcut is -rpf, and I will call it the PVsyst report.pdf. And this is it. I hit enter, and I get some notifications. First of all, I have no specific license for PVsystCLI CLI on this computer, the first one, but I still have this trial calls 239. So you see that 11 have already been executed on this particular machine. And if you do this on yours, on your machine, you will start with 250 and get a countdown here. And then you see PVsys notifies that it's loading the project, loading the variant, and then running the simulation. You see the progress going up from 0 to 100%. And then finally some messages in the end. You might get some warning messages. Like here, the inverter power is slightly oversized. And these are exactly the same warnings that you would get if you would open this variant in PVsys. These orange messages that show up and guide you or give you warnings and indications in PVsys are the same ones that will be showing up here. And finally, it will create a CSV output file by default, which will be put in this default directory. And now it's generating the PDF report. On this particular PC, this takes quite a while, so I will show you the other results and let him generate the PDF report while we are looking at the files that have been generated. So if I come back to my workspace, PVsystCLI 80 data, user hourly, there is a file, bifacial multi-orientation, that's the name of the project, VC0, the variant, and if I increase this, it's a CSV file. And if I open it in Excel, for example, you will quickly see that, I don't see it right here. It did not open, but it's a CSV file containing the results from my simulation. So meanwhile, the PDF report has been generated. So let's look at that as well. It's been generated in the folder where I called PVsystCLI, CLI, but I could have put a path and then have it written in some other locations that I would like to choose. And the PDF report here now is exactly the PDF report that you would get from a regular PVsystCLI simulation for this variant and this project. Okay, so this is the basic feature. You see that you have some output here. You can control the verbosity of this output with different option parameters as well. And you can even redirect this output into a log file. If you have a fully automated workflow, you don't want to see these things scrolling down some terminal. You want to have this output in a log file that you can look up later on. So this is the first or the most basic thing that you can do with PVsystCLI. But of course, in reality, you won't be typing in a real use case. You won't be typing commands on a terminal all the way to use PVsystCLI. The whole idea of this is to automatize all this process and to integrate it into your workflow and to operate PVsystCLI from scripts. And these scripts need to be Windows scripts because PVsystCLI, like PVsyst, has to run on a Windows platform. So this is necessary. But on your Windows platform, you can either use the Windows batch files, you can use Python scripts, you can use R scripts or any other scripting environment that is able to call Windows command lines. And also there, to give you some use cases and some examples, we distribute with PVsyst real examples that you can just look up, try out, and I will just show you one of these examples right now. So coming back to PVsyst, if you go into the workspace manager of PVsyst here, manage, you see that there is a PVsystCLI demo folder in your workspace, which contains different examples for Windows batch files, Python and R, but which by default is empty. So if you install PVsyst, we keep these directories empty, but you can populate them by clicking here on Reload Templates. So if I click on Reload Templates, PVsyst warns me that it will overwrite any files that might have the same name in these template directories. If I click yes, you see that now if I unfold this, that files are showing up with examples for the batch, Windows batch files, Python examples, or even for the R language, which is a scripting environment for statistical analysis. So these examples were now created in our workspace. If I come back to my Windows Explorer, I see that there is a new folder called CLI. I can go navigate into there. I have the subfolder resources, and here I have the examples. And here you see the examples that were created. And we will look into this Windows script. And you see there is a simple simulation here, which basically does what we did manually right now. So if I open this, you see that there is a list of commands that sets environment variables. If you are not familiar with Windows shell scripts, let me just say that this defines basically the paths and folders where you want to work on. And the command which invokes PVsystCLI CLI is here at the end. We invoke, run simulations with the different parameters that were specified in these variables in the first part. Yeah, and this will basically do exactly what we did manually. Of course, also this example is quite simple and not a real use case. Something which might be more interesting is now this next day forecast example. And I will quickly show you what it does. So I will come back to my presentation. And the scenario basically we are looking at now is that you have an existing PV installation. You are collecting data, you are monitoring it, and you are measuring also your weather data. And as the weather data is updating, you want to rerun your simulation with the new updated weather data. Or, so this would be looking into the past, or like the name of the example suggests, you have a weather forecast for the next day, and you want to run the simulation with that to get an estimate of your PV generation of the next day. The idea is the same. Yeah, you have updated weather data, and you want to rerun your variant with that data. So basically you have to have two steps. You first have to import the weather data into PVsys and generate the MET file. And the second step, you then run the simulation with that weather file. And instead of doing this manually on the terminal, we have this script here which does the whole of the work for us. So again, we have a first block on this example which sets variables with the different file names and the different paths on which we work. We see that there is a CSV file with the weather. Yeah, it's a non-PVsys format, and this will be converted into a MET file with this name here in a first call to PVsys CLI. This you see here in the end. Create weather file. The first call to PVsys CLI is called convert meteo, and it takes the CSV file. It takes also a so-called MEF file, the site for which you want to generate, and will generate this MET file. So the MEF file is a meteo format file, and it's basically the file that describes the contents of your CSV file, where PVsys will find the columns for the different variables of global horizontal irradiance, ambient temperature. This MEF file you generate with PVsys, so with a graphical user interface, but you have to generate it only once for your CSV data format, and then once you have generated it, you can use it for this PVsys CLI invocations. And then the second call to PVsys CLI is the last line here, where we run the simulation, and now we specify the weather file that was generated in this first step. So let's do all that in our command line. Coming back to it. Yeah, sorry, no, it's not this what I wanted to do. I wanted to go to my examples and just run this batch file. Yeah, by just double clicking on it. This will also open a terminal, and you see here there's very little output. This is because the output that we before saw on this command line here, when we did it manually, is now being redirected into log files. And you see different steps have already finished. The first weather data was converted, the simulation was run, and now it is done, and we can just look up the output of our results. So let's do that very quickly. If we come back to our workspace, examples, results, we see our example next day forecast with the log files. So these are the simulation logs, which show us basically what before we were seeing on the console. We have now in this file. This is the part of the weather data conversion, and the second one was what the simulation. No, the other way around. So this is the weather conversion, and the other one was a simulation. And then also the results were written into this subdirectory here. And finally, the weather data, so the MET file that was generated, was also put in a separate directory. If you would use your PVsys workspace, you would have your script writing this met file directly into the workspace, into the subfolder Meteo, which is normally where the met files reside. So you see, you can automatize all these calls to the command line, to PVsystCLI CLI in these scripts. We've seen a Windows script, but there are also examples with Python scripts. You have exactly the same example here in Python format. If I open this, if you're familiar with Python, you might be able to read this code. But basically, these lines in Python perform exactly the same thing that we did with the batch file from Windows. And we have here the two invocations of PVsystCLI CLI at the end for converting the weather file and for running the simulation. In these Python examples, there is one more slightly more sophisticated example, which is called pseudo-hourly, and I will quickly explain you what it does. So it's another use case for using PVsystCLI CLI, and here the idea is that you have a sub-hourly minute file and you want to run it with PVsyst, and this is of course right now not possible. The PVsyst simulation runs in hourly steps. The sub-hourly simulation with PVsystCLI is foreseen for the next version 8.1, but right now you are limited to hourly simulations. But there is a workaround or a procedure to do that with the current PVsystCLI version, which consists in slicing your weather data into 60 slices for each minute within the hour. This gives you 60 weather data files or 60 CSV files for each minute in the hour. You can then convert that into the PVsystCLI format, run the simulation on it, and then reassemble the 60 results into a minute output. This is basically what you see here. Split your data, you generate the weather files, you run the 60 simulations, and you group results, and the result is shown here. You have really a 1 minute resolution for your simulation. I will not go through this example because it takes some time, but I want to say two things. If you do this, you could do this also with the batch mode in PVsystCLI. It's slightly more complicated. You have more manual steps. With PVsystCLI CLI, you can really automatize all these steps. This is the first advantage. And the second one is that you can run all these different calls in parallel on your computer. So with the batch mode and with PVsystCLI, you are limited to a single thread which executes sequentially all your simulations, but PVsystCLI CLI can be run in parallel. So you can run all these 60 simulations in one go, and that will execute much faster than if you would do that just with PVsystCLI, the graphical user interface or the batch mode. So the example in Python that does this is this pseudo minute sub-hourly simulation. It's slightly more involved, a little bit more complex. It invokes a second Python script which is next to it, which contains the CLI command line calls. Just one warning: if you try this out yourself, you can run this Python script. It will work. These are out-of-the-box examples which really work. All the files you need are in there. But be aware that these will be 120 calls to PVsystCLI CLI. You have 60 calls for converting the 60 weather files and 60 calls for the 60 simulations. So this will use up your quota of 250 trial calls quite quickly if you do it more than once.
If you want to try it, you can use 15-minute data, and that's
that will be
only
faster.
8 calls. Yeah.
If you do that with 15 minutes or 10 minutes data, of course, this is much less expensive in terms of trial calls. Okay, and this is basically the two examples I wanted to show you or discuss with you here for PVsystCLI. Now a short outlook to what we want to do in the future. So the next step for PVsyst 8.1 will be to integrate also the batch mode into PVsystCLI. And this might sound redundant because the batch mode is meant for many simulations one go, and PVsystCLI can do that. But the nice thing, or what it really does, that it will give access to modifying the simulation parameters with PVsystCLI. So the batch mode in the batch parameter file can modify the variant that you are simulating. It can change the pitch, the tilt, and many other parameters in the batch mode can be varied and manipulated. And this would allow you in an automated workflow to impact now on the simulation parameters, modify your variant automatically and run the simulation aside and get the results. And there are basically two use cases that you could imagine for that. First one is automatic optimization of system parameters. Imagine you have a system with a storage and self-consumption, let's say, and you want to size your PV field and your battery optimally for your load profile. Then you could run many simulations with different battery sizes and different PV capacity and have PVsystCLI CLI do that automatically for you and generate immediately results that you could visualize in plots which find you the optimum, for example, here for the net present value, with a financial analysis behind it. This is the first use case. The second thing you could imagine are fully automated sensitivity analysis. So let's say, just as an example, that you have a bifacial simulation and you don't know exactly the ground albedo you need to use because there's some uncertainty on it, and you want to understand how this uncertainty of the ground albedo propagates to the result of the PV generation. Then, since the ground albedo is a parameter that you can change with the batch mode, you could then run PVsystCLI CLI for different ground albedos, regroup the results, and get the mapping of this uncertainty to an uncertainty of your PV generation. So this is also a useful way to use the command line interface in a more automated way to get quick results. And with this, I'm finished with what I wanted to present to you, and I thank you for your attention, and we get to the part of questions and answers.
Thank you, Bruno. That was very interesting. So let's have a look at the questions. I'm going to try to make this bigger. Okay, so I think our moderation team, and thank you to them for all their work, have already answered a lot of questions, but they left us with the toughest ones. So let's try to deal with them. So let's take them in order, maybe?
Yes.
Okay, so I'm going to ask this first one. Is there any, answering. Is there any big change in the physical model? Since the several orientations can also be modeled separately, I guess in version 7, and then merge in an Excel file.
Yes, so the physical models behind did not really change. We optimize the calculations, we make them more efficient, but basically it calculates like PVsys 7 did also. The nice thing of putting this together into one is, of course, it's more convenient instead of generating 4 or 5 separate simulations and merging them in Excel. And the second thing is that indeed you could have interactions between the simulations. For example, if you have 2 patches which need 2 bifacial models and you connect them to one big central inverter, of course they would interact. The clipping losses would need to take into account both of them. And this, of course, this is much harder to do if you need to do this in a processing step on the results of PVsys. So there is still a very big advantage in the possibility of doing this now all together in one single PVsys simulation. I will ask you the second question, which is, in a utility scale project that has different orientations inside the same area due to the terrain, when you go to project settings and increase the tolerance like you did in version 7, does it affect the report results or only the number of orientations that PVsys will create?
That's a great question. So basically, we want to change the way we think about orientations. So indeed, in version 7, it was possible to separate the orientation based on a certain tolerance, which just generated groups of tables that fit into one orientation. But since we are describing and linking the orientations also to the subarrays, so each subarray will be attributed to 1 or 2 orientations. What we find most important is to group the objects that are spatially close together and will fit into the same inverter into the same orientation. And this is usually what people also do, what you would do in the field, in that you would have a specific nominal orientation and group that into one inverter. And so rather than using the tolerances, the idea is rather to go to the 3D scene and make your own delimitation just by selecting the different tables and say, okay, these are this specific orientation number 1. These others here, they will have some different properties, so we're going to make them orientation number 2. These ones are trackers, so let's make them orientation number 3. And so in that way, you don't need to use the tolerance anymore. I just need to add that there is still a parameter that affects this tolerance. This just affects now the warnings that you will get in your project development. So you will see a warning telling you, okay, within this orientation, there are things that are very different, and so maybe you should be careful about it. But there won't be an automatic recognition of the orientations.
Thank you, Michele. I will ask also the next question to you, which concerns bifacial PV vertical installations. There is no change from version 7 here, and the question is, do you have plans on improving this specific type of config? For example, the backside does not consider soiling, far shading, and near shading from the 3D model.
So yes, we have plans on improving this. It was just not realized for PVsystCLI 8.0, but within version 8 already, so in the future major updates, we are looking towards improving the bifacial model as well. It just will take still more development time. Okay, let's move to another one now on CLI. So can we generate a TMY out of multiple years of .met files? And some of the other questions are related to that. So yeah.
So that's also a nice question, because the answer is quite simple. No, not yet. But it's a good point, and we were looking for use cases for PVsystCLI. CLI. In fact, this did not occur to me yet, and we will put this in our roadmap. Certainly, this seems to be a useful thing to do, because it's quite a lot of work if you have to do all this manually. And if you could just take several files that you have, several weather files that you have, and generate automatically a TMY out of it, that would be a nice thing.
And I think I can skip over to this second question here, which is, so if you have import 6 months of weather data on site, then how does it work? Do you update the TMY already existing MET file, or do you create a new MET file? So what are you doing with this new measured weather data?
So right now, it's just a step that I've shown and explained to you. So you have a CSV file, and you can convert the CSV file into a MET file. And this will be a single MET file. Then you can run a simulation on it with PVsystCLI, or you can use it, of course, in regular PVsyst. And if you have done this for, let's say, 10 different MET files, you can use the tool in PVsyst for the TMY generation and just create them. So the step getting from CSV to .met would be automatizable, and the next part not. But of course, yes, the question is if PVsystCLI, for example, also could try to process files from data providers, formats from existing data providers. And this right now is not yet possible. You have to go through this custom conversion that we have. This was the first approach, but certainly we are looking into the possibilities of using PVsystCLI also with other data formats, not only the custom format.
Yeah, and eventually combine things.
Yes.
I mean, we're looking towards many improvements, of course, in the future.
And it's nice to see your feedback, to understand the use cases, because this will guide us in what we will develop and then put into the new versions.
So I also have this question for you on CLI. So will new installed versions of PVsyst recognize the CLI subfolders and files? So imagine what happens if you update, looking for example, if you install 8.0.4, I think this can be installed parallel to 8.0. 3. So
Yes.
what is the interaction with PVsystCLI? CLI?
PVsystCLI CLI is very flexible because you can specify your path and folders wherever you want to put them. They don't necessarily need to be in a PVsys workspace. The projects, PVsys projects themselves, of course, need to be in a PVsys workspace, but the results, the MET files, as you've seen, they can be placed anywhere by PVsys CLI. So it depends on how you set up your workspace. When you upgrade PVsys, normally your workspace is kept. Yeah, your workspace is not touched, it's taken over to your new PVsys installation. So the same thing will happen if you upgrade PVsys CLI. Your workspaces will be taken over. If you don't change a major version, or the workspace will simply stay the same. Yeah, there will be a backup copy if you go to new minor versions, so that you can recover if there's a problem. But basically you will just see the last workspace that you are working on with the new installed version.
And I think just to check whether the version is correct, if you're making updates, because with PVsys you can very easily see that you updated, there is a command in CLI that is check the version. So I don't remember the name, I think it's /v or something like this.
Yes.
But this way you can check that this was upgraded properly.
So next question, is it possible now to obtain results in a minute resolution?
I guess it's for me then.
Well, I can also.
Yeah. So right now, no, it's not possible, but you can get to it through the pseudo sub-hourly simulation. So that's what Bruno showed us in 2 slides before the end. So the idea is that you can run multiple simulations and then aggregate the results. And if you are keen on scripting, you can script that out very easily now with PVsys CLI. So PVsys itself does not give a minute output, but you can build a machine around it that generates that.
Okay, next question will be for you. It would be really helpful to be able to get the waterfall for the different orientations in order to track down the cause of changes in the results or check whether we made any mistakes in the setup.
I agree with that. This is part of our roadmap. However, it necessitates quite some development for that, but we'll be looking into that question, of course. Right now, the only way to track down the different orientation would be to do different simulations. Yes. And separate that.
Yes, maybe let me add to that. You can already get the breakdown for different months in the simulation of the waterfall, but not the different orientations. Mm-hmm. But in the same spirit, we could implement something which goes through different orientations and shows you the waterfall different. It's a very good suggestion.
So maybe we just answer a last one because we are close to the end. We will try to keep a record of the remaining ones anyway.
So let me ask that to you. What is the uncertainty of topography imported in PVsystCLI 8?
Yeah, actually, I'm not sure. So the topography itself, I mean, we have a specific like API that we're using. I think it's Bing.
Yes.
Yeah, it's Bing. So I would like to refer you to that, to their support directly. Then for this kind of question, which I'm not an expert in, you can also send us an email to support@pvsys.com. And so then we can look into it in details and give you a precise answer. Maybe, and then following that, we should add that to the help page. I think it's a very good question.
And this is a good finishing remark. I mean, if you have, we didn't have the time to answer all your questions, but of course, you know that support@pvsys.com is our technical support line where you can put all your questions and we try to answer as well and as fast as we can. And with that, I would like to thank you for joining this webinar. I hope it was useful for you and that you got an idea of what is possible now with these new versions. I'm now saying goodbye. Thank you again. And thank you also, Michele, for your part. Have a nice day or a nice end of day, depending on the time zone you're in. And hope that you're happy with the new PVsystCLI 8 version.
Thank you for attending.